SN1 and SN2, I'm going to be doing a football lesson, right, so for guys in my class. And before you discuss SN1 and SN2, you need to know what R and S and the Can-Ingo-Prelog rules are. Have you discussed that? No? Okay.
So we don't have to go.
Yes. Okay.
Yeah.
Depending on at a chiral center, meaning carbon is sp3 hybridized, right? Meaning that in space the bond numbers are 109.5, and they find themselves spaced out in a tetrahedral arrangement. And when this happens, much like my left hand and my right hand are mirror images of each other, but if I try, no matter how I cannot superimpose my right hand on my left hand. So we say that they are enantiomers. There are three different terms. There's something called dextrorotary and levorotary. There's R and there's S. There's also a plus and minus. Most proteins we say are levorotary and S. So I wanted to provide you with a chart of what you'll need for this class, and I have to ask you to commit this chart to memory, okay? And eventually your professor will get to something called optical isomerism. And as you can see at the bottom of the chart, it says enantiomers and diastereomers. Okay? Sometimes we need molecules in our bodies to like enzymes recognize whether a molecule is R, S, or not. And especially when we manufacture certain pharmaceuticals. Some pharmaceuticals like ibuprofen have R and S configurations because they have chiral carbons. One popular medication called thalidomide, much like they cured morning sickness for women that were with child. In the 1940s, it was.
Oh, the guy on American Horror Story was his defect is from this.
Say that again.
Does anybody watch American Horror Story?
Yes.
The guy with the little chicken arms. I watched a documentary about him, and he has those chicken arms because of this drug.
Right. Could you tell me, did he come to your class?
No, I watched it online.
He's like kind of famous.
He's like famous. He's like a
He's
British
famous.
actor.
Yeah, he's famous.
Well, in the okay, do not this is thalidomide, okay? In the 1940s, tell us about this person.
His mom took thalidomide for morning sickness, and so when he was born, the doctor, it was in the 60s, I think they were still using it, or maybe it was the 50s, but he was born and all of, like his whole, like everything was completely fine except his arms. I think with the nerves don't develop right, so they don't fully develop. So he has like half arms, and they're like full wings.
His arms are very shortened, and so is his legs. So, like pharmaceutical companies have to determine when they that was a very big scandal. And imagine if you're caring for a child, your newborn child is now, you had no way of determining whether this child was going to have a birth defect before it was born, and then all of a sudden, at the day your child is now born, has this birth defect due to some medication that was being marketed. Can you see these molecules? So in thalidomide, there are. Thank you, Aspen. One of the molecules is R, and one is S, meaning one rotates like sinister, one rotates like clockwise, which is in the R direction. This molecule is used in the treatment of cancers. Most all molecules have mirror images, and depending on the number of chiral centers, it has 2 to the n number of chiral centers. So on the next page of this chart, a molecule you're going to be studying today is called caravone, and I found a popular article, the application of S-caravone in the synthesis of biologically active natural products. And caravone, which you're going to be isolating today, is a major component of caraway oil. And it's used as a chiral starting material as a synthesis of biologically active natural compounds. So it's possible to take the S-caravone.
So wait, what lab are we doing today?
We're doing caravone. We're doing this lab.
Okay, sure.
We're doing this lab. And today you're going to do something called...
Wait, are we skipping a lab?
No.
Is this nuclear? Yeah, what about...
Yes. No, we're doing that lab last. We're doing that lab last. This class does that lab last. And that's a real lab. So I'll make sure you're prepared for it. And I already have videos from Dr. Lee's class. Today...
Wait, the pre-lab you put online though is for that, wasn't it?
Yeah, there's a card.
Oh, I might have put it in the wrong, yeah. I might have put it in both. Let's look, but did you see this PowerPoint? Did you have this PowerPoint in your possession? It should be there now. We're doing a caravone lab today. I didn't give it to you?
We did the pre-lab for nucleotides.
I did substitute.
Yeah, I didn't know.
It's okay though, we can just leave
All right.
lab last and do this today.
That didn't hurt because you're going to do it shortly, okay? Caravone, I introduced it somewhat. It has an R and an S, okay? It's a naturally occurring organic compound found in spearmint oil, extracted from mint leaves. Many pharmaceuticals, aspirin is extracted from trees. Taxol is extracted is an anti-cancer medication extracted from plants. Resveratrol is an antioxidant extracted from grapes. Curcumin is an antioxidant extracted from turmeric leaves. A lot of anti-cancer agents and pharmaceuticals are extracted from plants. And at some point in time, the organic chemist is married to the biologist. And what the organic chemist tries to do is to synthesize molecules in the lab that are found in nature. Okay? Spearmint oil is a complex mixture of terpene compounds, typically comprised of 60 to 70% L-caravone, 4R minus caravone. So this is a PowerPoint that you have in your position that has the two enantiomers of caravone. Caravone forms 2 mirror images of enantiomers, an R and an S. The R smells like spearmint. Don't use the spearmint today. Okay? The S smells like caraway. That caraway works. Okay? You're gonna isolate the S caravone and then create a derivative of it next week. They're the same molecule, but in some people, 10 out of 12 people most often are able to distinguish the R and the S by olfactory, by their nose. So imagine the enzymes in our body being able to decipher what molecule is R or S.
So R is minus and S is plus?
Not all the time,
Okay.
but
in
this
case,
time. Some animals are able also to distinguish between these enantiomers. In proteins are levorotary and S, meaning that the LS designation does not always work. This is something called chiral recognition. Chemists, especially the analytical chemists, are able to devise very, very fancy instruments in order to separate pharmaceuticals based on whether they are R or S. Okay? Chiral recognition. So humans and other mammals are able to distinguish by scent the R or S, the left and right hand of this molecule. And this is another article that you have. It's also used in the treatment of prostate cancer, where I can make a derivative using this molecule, make a derivative and put it on an anti-cancer agent. So I also put this abstract. It's the synthesis of L-carvone and limon derivatives with increased anti-proliferative effect and activation on ERK pathway in prostate cancer cells. So it's just really just using this molecule to place it on an anti-cancer agent, using it as a starting material for chlorination, nucleophilic substitution, which we're going to discuss, and reduction, which our class is going to discuss in depth shortly. And these derivatives are characterized by mass spectrometry, which I know a lot about, and about proton NMR, which this college has a 400 megahertz NMR. Okay, so I want you to get, maybe we could talk about some machines shortly. Okay, so to a round bottom flask, you're going to add 15 grams of carrying leaves, 100 milliliters of deionized water, or in stones. You're going to use a steam distillation apparatus. We had a pre-lab, and we talked about steam, fractional, these different things. So we're going to do a steam distillation today. Okay.
So is this distillation just like the distillation we did in the other lab?
Yeah, steam distillations are great because they're good for separating oils and non-volatile impurities. Another liquid boiling point is at least 25 degrees higher than the first, which suits our purpose as fine.
But you don't want us using the micro distillation apparatus, right? Because we're
No, you're going to use finally, because I had this class in 1988, and there was nothing microscale. Meaning, if you didn't finish, like, you had large equipment, and you had a partner, and you had to finish that lab because you're going to medical school. And if you didn't finish the lab, you would have to hustle lab time. Meaning, if you didn't finish the lab today, you would have to go to the 5 to 9 o'clock lab, and then wake up at 7 in the morning, and if you didn't finish that at that time, go to the 8 to 12 lab tomorrow. Meaning, there was no, if Dr. Lee said, I need the % yield for this compound and the derivative, then that was it. This class was it's been like, I guess maybe it was kind of too much. It was like too much for one person. I guess maybe you still learn effectively using the micro scale equipment. However, today I'm happy because you're going to use macro scale equipment, okay? And you do a real lab today. And this is the setup. Again, I love all my students and all my classes. One of my students, I saw she was like a little apprehensive when she came toward this instrument, okay? So I want everybody to get maybe accustomed to, it's one of the few instruments we have in the lab. You're also going to do gas chromatography. And this is, in the next class we do something called NMR. In organic chemistry, we do two techniques called FTIR and NMR. They're very popular in characterizing molecules. We have this exact instrument here, a Bruker 400 megahertz here. And this instrument is just like a MRI instrument. You know what MRI is, right? MRI, CAT scan. So it has the same principle. So it wouldn't hurt to learn, especially on your way to medical school. Okay? So it worked for Caravone, not the Spearmint. It's going to take 2 hours. Maybe not with the Caravone. So I'll try to. Now I'm going to come around with videos. Okay? And you have to first discard the 1 milliliter when boiling. Collect first the 50 mLs and stop collecting at this point. Meaning you got to start the distillation and then stop it. Add 75 milliliters of deionized water and then continue again. Take the distillate in the second 250, add diethyl ether. And you also need to, at some point in time, extract with the organic solvent. Remember that the organic substance goes into the organic layer. So it's going to go into when we do carry out the extraction, the diethyl ether layer will have the compound. Just as safety, don't throw anything out. That's the best way to look at it when you go to it. And you guys are experts. So it says, say the top portion will be the ether layer. So the top portion will have your compound. Then we'll take it over to the rotary evaporator, which you have instructions for. It's real easy to use. And I gave you a handout. Does everybody have this handout? That one? That one? There's also something called REU. REU are summer experience programs. You don't have to be an organic, you don't have to be a chemistry major to have an REU or a bio major to have an REU. You get paid like $4,000 to $6,000. You guys are all great. I can write your recommendation to go to one. And we probably have one of them here. I know Dr. Sharma. I think he has some summer programs. And something you do for fun. You do research over the summer. So I want you to get acquainted with this instrument. And we'll have fun today. Okay? So, are you have any other questions? Alicia? Zach? Okay.
Is there only one roto?
There's only one, but
That means OTD is higher or less the other.
no. That means you have low returns. Low returns.
So what point are we stopping at today? Because you said we're going to continue the line.
After you finish this,
Okay.
and then you're going to place your Caravone in a vial. Then we have to do something traditionally, is make a derivative. Meaning I didn't have all this fancy equipment when we had organic chemistry. You have to do something called make a derivative. So we're going to do that next week. Any questions? Okay, and everybody has a evaporator rotor trap instruction manual, right? Okay, and you're all more than, I'll have videos. You're all more than welcome to come to my SN2 lesson today. And that's it. Let's hit the lab.